Hello friends, so here is another question on superposition principle. So here the question is that in a triangle ABC, we'll draw the triangle, okay? Let us draw the triangle as we read the question. So in the triangle which is given, it is given as this, okay? Like this. Then we have and like this, okay? Like this is the triangle which is given and is specified as A, B and C. Okay, this is the triangle with the sides 5 centimeter, 4 centimeter, 3 centimeter, and then we have charges, okay, plus 1.2 into 10 to the power minus 8 coulomb, minus 1.6 into 10 to the power minus 8 coulomb, and 1 coulomb, which are placed at A, B and C. So plus 1.2 into 10 to the power minus 8 coulomb, then B minus 1.6 into 10 to the power minus 8 coulomb, and 1 coulomb placed at A, B and C respectively. The lengths are specified. We have to find the net force, the total force acting on this 1 coulomb charge placed at C. Okay, this is our objective. Again, it is an application of superposition principle. So here there will be two forces acting on this charge C, okay, because of charge A and B, interaction with A and B. It is interacting with A and it is interacting with B. So these two interactions will produce two forces. Because of charge A and C interaction, there will be a repulsion type force in this direction. Let's call it FAC. Okay, it is specified the force vector this. And because of charge C and B interaction, this is plus, this is minus, there will be an attraction type force in this direction. Okay, this direction. Let's call it FBC. Okay. Now here, this angle is 90 degree. Why? Because if you see, this is a right angle triangle where the hypotenuse 5 square is equal to 3 square plus 4 square, 9 plus 16, 25. Pythagoras theorem. So this is 90 degree. So this angle will be also equal to 90 degree, which is the angle between the vectors FAC and FBC. Okay. So first let us determine FAC and FBC, then we'll proceed. FAC is equal to 1 by 4 pi epsilon 0 QA QC by RAC whole square. So here QA is equal to so 9 into 10 to the power 9 first, 1 by 4 pi epsilon 0, then QA is 1.2 into 10 to the power minus 8 coulomb, QC is 1, RAC is 3 centimeter, which is in meters 0.03 meters, that is whole square. So if we calculate, it is coming around 9 into 1 plus 1. It is coming around 1.2 into 10 to the power 5 Newton. Okay, so please friends, be careful with these calculations, double check them. Okay, so it is a repulsion type force. Okay, repulsion type force in this direction away from C. Then we have FBC. FBC 1 by 4 pi epsilon 0 QB QC RBC whole square. 9 into 10 to the power 9 for 1 by 4 pi epsilon 0. QB is minus 1.6 into 10 to the power 8. Here don't put that minus sign, here just put 1.6 into 10 to the power minus 8. QC is 1. RBC is 4 centimeters, so that will be 0.04 whole square. So if we calculate, it is coming around 9 into minus 1.6, 0. So it is coming around 0.9 into 10 to the power 5 Newton. This will be an attractive or attraction type interaction, okay, force. So here minus sign means it is attraction, plus sign means it is repulsion. No, if don't put this sign here, we are just determining the magnitude, okay. For direction, we will write in the bracket attractive type force, this is repulsive type force, okay. Now we have determined FAC and FBC, okay. So here let us draw it separately, okay. At A, we have one of the forces FAC and another one is FBC. Sorry, this one will be slightly short, the length of the vector will be a little bit short as compared to this, because it is of lower magnitude, okay. So this will be FBC. Okay, this one is FBC. Angle between them is 90 degree. So the net force acting on A will be the resultant of these two forces, F resultant. So that will be, using basic law of vectors, the resultant vector will be equal to FAC whole square plus FBC whole square plus 2 FAC FBC cos 90 degree. That will be equal to 1.2. This will be 0 because cos 90 degree is 0. So this will be equal to 1.2 into 10 to the power 5 whole square plus 0.9 into 10 to the power 5 whole square. That will be equal to so it is coming around 1.5 into 10 to the power 5 Newton. This is the resultant vector magnitude. This is the magnitude, okay, because it has been asked to find the total force, okay, net force acting on this, 1.5 into 10 to the power 5 Newton. This. So again, a very basic question, simple question, but it involved application of Coulomb's law, then about application of the resultant vector formula, this, and then we get the answer. So that's why basic understanding of scalars and vectors is very important. I have made separate videos on scalars and vectors in the basic physics playlist. You can check that out, okay. So this is the solution.